In this tutorial, I'm going to go over the difference between fission and fusion. So let's begin. In your notebook, you're going to glue in some of the little pictures that I've given to you. So as you see the pictures in the notes today, make sure that you follow along in your notebook. Okay, so let's talk about fission first, and this is the picture for fission. Fission is the splitting of a nucleus. So fission is just another word for splitting. This process releases 2 to 3 neutrons and 2 smaller atoms, along with some energy. If you, even though I didn't write that down, could you please write that into your notebook? Plus releases energy. So let's talk about a sample fission equation. So we have an isotope of uranium, uranium-235, and if we shoot a neutron into that nucleus, it's going to turn into, for a moment, uranium-236, which is unstable. And when that happens, the nucleus is going to split into 2 smaller elements, krypton-90, for example, and barium-143. Now, look at the atomic masses on the left. 235 plus 1 is 236. And the ones on the right, 90 plus 143, is 233. So what about the extra mass? Well, the neat thing about a fission reaction is that it releases 3 neutrons, 2 to 3 neutrons, in addition to those 2 smaller atoms. And so if you now add up the atomic masses on the right, 236 and 236 on both sides, they're equal. We have to conserve that mass on either side of that arrow sign. So why is that important that 3 additional neutrons are released during the fission process? Well, this can create a chain reaction. If you have a bunch of neutrons that are released when fission occurs, those neutrons can now hit other uranium-235s. Those in turn release neutrons and also split. Those neutrons can then in turn hit other uranium-235. And this process continues. It's a self-sustaining fission process as long as the neutrons and fuel are available. So a chain reaction is a series of fission reactions. These are caused by the release of additional neutrons in every step. So as long as you continue to create those neutrons can then help other uranium go through fission. All right, and that process releases lots of energy, and that energy can be captured to produce electricity. Fission, let's go back if I can, yeah. Fission, this process is what's used in nuclear reactors. Nuclear power plants use fission to produce the electricity. Okay, now let's talk about fusion. This process is a little different. It's making one larger atom from 2 smaller atoms. When those 2 smaller atoms are joined, it releases lots of energy. This is the process that's happening inside of the sun. It's what produces the light and the heat that you feel from the sun. So let's look at a sample equation. So we take, those are 2 isotopes of hydrogen. The little plus sign is a proton. So there's 1 proton in deuterium, another proton in tritium, and fusion occurs to produce something that has 2 protons, along with a little neutron that's extra. So what does this look like in equation form? So if we take hydrogen 2 and we add hydrogen 3, it produces helium-4, along with a little extra neutron. Note how the atomic mass on the left of the equation, 2 plus 3 is 5, is equal to the atomic mass on the right, 4 plus 1 equals 5. And so that is major differences and explanations of what fission and fusion are. I hope you enjoyed it.